Let me start congratulating Professor Eric Dietzenbacher for his recent prestigious royal decoration by the city of Groningen. And congratulations, Eric. Okay. And for let me introduce our speaker today, Professor Barlos. Okay, Barlos is full professor of economics of technological progress and structural change at the University of Groningen, and is also member of the Groningen Growth and Development Center. I think we will all agree that to define Bart as a world expert in multisectorial modeling and one of the main promoters of the input-output methodology to tuning in economic behaviors and to answer key questions in economic development related to technological change, innovation and technology diffusion, international trade, and its impacts on productive structures. Bart always encourages us to look further and to inquire into the economic nature of the models and the results. Professor Loos was editor of Economic System Research, the journal of the International Input-Output Association, for nearly 10 years, and he's also member of the editorial board of Journal of Economic Structures. His research in the fields of input-output analysis, global value change, international trade, or technology spillovers has been published in more than 100 articles, some of them in leading journals, as is the case of American Economic Review, Journal of Economic Development, Development Economics, Journal of Economic Perspectives, Economic System Research, or Economic Policy, among others. But has participated and supported different research activities in Spain, and has promoted different networks, and has always accepted our invitation from the SHAIO. And in fact, he was invited lecturer at the 6th Input-Output Workshop in Madrid 5 years ago, I think in 2017. And today we have a new opportunity to learn from him and his work. And specifically, Bart will share with us his reflection on the present and the future challenge for input-output research with the inspiring talk entitled Implication of the Global Value Change Revolution, Next Step. So thank you very much, Bart, and the floor is yours.
Okay, thank you very much, Rosa, for the nice introduction. Let me see, I'm going to share my screen. Hopefully this will work. Yeah, oh, wait a second. Oh, yeah. Can you see the slide in full screen now?
Yeah.
Yes.
Yeah, okay, thank you very much. Well, thanks again for the opportunity to give this presentation. This is the title that Rosa mentioned already, but as you can see, there is a question mark at the end, which I added, because I'm not going to present results or outcomes of finalized research. My main aim is to hopefully give some inspiration for further sophistication of methods we use in input-output analysis to study global value change. And of course, there are opportunities to disagree with me about which avenues could be fruitful and which ones are not. So that's why I added the question mark. And then I should also mention that this presentation was also made possible by Chanja Ye. I think he is in the audience. He's a colleague of ours here at the Groningen Growth and Development Center at the Faculty of Economics and Business, and he helped me in preparing some graphs and doing some analysis. And Luc Appels was a former master thesis student of mine, and I also borrow from some of his work, which he did about 2 years ago, or slightly less than two years ago. So recently, many people have been talking about global value chains and the importance of these due to what happened at the start of the COVID-19 crisis, when the Chinese factories had to suspend their production activities, and the consequences this had for production activities and consumption elsewhere in the world. But there are, of course, many more examples of events in which global value chains play an important role. And here I would like to focus on what happened when this Boeing airplane type crashed twice in a relatively short period of time, and the Boeing 737 MAX was not allowed to fly anymore. This had, of course, implications for the production activities of Boeing itself, because many purchases were cancelled. But given that many of the components that go into such a Boeing airplane come from many different countries, there were obviously many more countries that actually suffered from this event related to the Boeing 737 MAX. And given that input-output analysis deals with production activities in which intermediate inputs and components and materials, etc., are needed, these are clearly examples of situations in which input-output analysis has its merits. Still, I would like to show in this presentation that there's more than this trade in components and materials that could play a role in studying global value chains from an input-output perspective. So before I'm going to show you some tendencies over time related to value chains, I think it's important first to give a definition, and hopefully that will help in forming ideas. So I will define a value chain, which is sometimes a global value chain if many different countries and or continents are involved. But I will define a value chain as all activities required to produce a final product. And quite often this relates to manufactured products, like capital goods, like products that we are using for a longer period of time, like a fridge or whatsoever. And quite often these final products do not involve services, because services tend to be produced very, very locally. So if we go to a theater or to a sports match, then most of the intermediate inputs that are the activities that are required to deliver this product are produced in a relatively small local economy. Still, service activities are included also in, as we know, in the production of manufactured final output. So financial services like banks, various types of business services are often included, and these will also be included in, let's say, what I will consider to be a value chain in what I will present later on. And it's important to note that this definition, if you would like to call it like that, has a long history in input-output analysis already. And for example, Pasinetti in 1981 was talking about vertically integrated sectors. This is a term that was also used by Ed Woof somewhat later. And this is actually very similar to what we are doing in input-output analysis. So this idea of a value chain or of a global value chain in itself is not very new. So how come that these value chains became increasingly global in nature? Well, first of all, there has been a long period of trade liberalization, and I give some examples here. Then transportation costs continued to be reduced, so it became cheaper to carry intermediate inputs from one location in the world to another one, and containerization plays an important role in that. And well, we have seen the Suez Channel crisis a couple of weeks ago, and then it's quite clear that transportation costs can suddenly become very high as well, but in general they have been declining. But the most defining change has been the information and communication technology revolution related to internet technology, as a consequence of which it's much easier nowadays to manage production processes remotely. So the coordination costs of organizing production activities across the world have decreased considerably. Some people call this the global value chain revolution. That's the term that I use here, but it has also been called the international fragmentation of production processes back in 2001 already by Bart and Kierczkowski. Richard Baldwin tends to call it the second unbundling. These are more or less similar terms used for similar tendencies in the world economy. Well, this global value chain revolution has led to renewed interest in input-output. When I showed the example of the Boeing, I already mentioned that trade in intermediate inputs plays an extremely important role in input-output. And this has led to a lot of interest in input-output again, quite often by people who do not belong to, let's say, the core of our community. And here are some examples. Some of these studies actually used methods that we are all very familiar with and that were sometimes or quite often actually introduced by Leontiev in the 1920s, 30s or 40s already, but then applied to different new phenomena. And as a consequence of this, trade economists, for example, have become very interested in this. But there are also studies, and these have been marked here in gray, which use input-output tables, and then mainly the type of MRIOs we have been constructing, or many of us have been constructing, but using different new types of models. So some of these, like Caliendo and Parro and Costino and Rodriguez-Clare, for example, they have developed these so-called new quantitative trade models that extensively use information contained in MRIOs, but not computing the types of multipliers, etc., to which we are familiar. So there's a diversity of new applications of input-output tables that now has found its way into mainstream top journals as well. And there are actually many more than I listed here. And unfortunately, and that has been something about which I have felt unhappy. Unfortunately, many of us in the IO community have not contributed to this, and I feel that we have missed a few boats, and we are mainly responsible for having constructed these very widely used data. But I think we could have done a better job as a community in using this data in new ways. And I hope that some of the ideas that I will discuss here might help in progressing into this direction. But of course, it's up to you as an audience to decide on whether you feel these ideas will help or not. I should mention, before I show you some stylized figures, that it might well be that some of the ideas that I will discuss here can be found somewhere in the literature already. I cannot claim that I have 100% coverage of the literature, but then innovation does not only depend on the, let's say, the rate of innovation does not only depend on the rate of invention, so coming up with new ideas, but also by the rate of diffusion. So if some of the things that I will discuss here have been introduced already, then I think there is still a lot of scope for diffusion. So if you would ask people about what happened during this global value chain revolution, and if they are asked to focus on this in the context of input-output, then many would most probably say that the share of intermediate inputs trade in total trade has increased. And here I have shown some figures which prove this in a sense. So the lines refer to data that are obtained from various data sets. So the one in black, the dashed line, is from Johnson Noguera 2017. The blue line refers to a new database that colleagues of ours in Groningen are developing and which will soon be published, what we call long-run world input-output database, which runs from 1965 to 2000. And here we have some of the more well-known databases like WIAT, like OECD, TIVA, and we showed, you can see here that the share of intermediate inputs trade in total trade, which is depicted along the vertical axis, has started increasing again from 2000 onwards, whereas before it was on a slight decline, or in the 80s and 90s, most probably it was more, this share was more or less stable. And it's important that trade in natural resources is not included here, because sometimes products that are only available at specific locations in the world must be traded to be used elsewhere. Domestic production capabilities are zero. So, for example, when it comes to the use of crude oil, this is not found everywhere. So you might say, how come that for a long time there was a decrease in the share of intermediate inputs trade? Final products can also be traded, and this is actually something that happened later on as well. So if you look at electronics production, for example, when Apple decided to have its assembly activities in China, the production of final products was clustered in a very specific part of the world, leading to huge increases in final products trade as well, because all these smartphones, etc., had to be shipped from China to Western Europe, the United States, Latin America, etc., etc. So this is one thing, but there is more, and I would like to focus a little bit on other input-output characteristics of this global value chain revolution, because I think having ideas about this might help in developing new ideas related to input-output and the global value chain revolution. So this is a graph, and I won't say very much about it, that I designed for the Elgar Handbook of Input-Output Analysis, which was edited by Thijs ten Ra. This is the shape of input-output tables a long time ago, when there was integrated production in autarky, so countries could not trade with each other. And here we have the new situation. And the darker the shades, the more filled these international multi-regional input-output tables are. So originally many parts of the input-output tables were actually empty or close to empty. And if you consider this over time, then more and more cells in the input-output tables became filled. And this led to three observations, and I'm going to give some evidence of these in a second. So first of all, over time, the value added to output coefficients became smaller. Second, the domestic intermediate input coefficients became smaller. And third, the imported intermediate coefficients became larger. And if you add the value added coefficients, the domestic intermediate input coefficients and the imported intermediate coefficients, then you must arrive at a value equal to 1 in the columns of an input-output table. So they are related. And again, I would like to show you some evidence of this. So here we focus on the trends in value-added coefficients. So along the horizontal axis, we have the own value-added shares in 1965. So this is based on the long-run WIAT database. And then along the vertical axis, we have the own value-added shares coefficients in 1980. So 15 years later. The green line, which you can hopefully see, is the 45 degrees line. The red dashed line gives the regression line through the origin. And here we have the equation. So the own value added shares in 1980 were 0.957 times the own value added shares in 1965. So they tended to decline. And this is based on a weighted regression. So large industries in the world get a larger weight in the regressions than small industries. And the importance of industries is indicated by the size of the circle. So each circle refers to an industry in a country in the World Input-Output Database, the long-run version of it. So there was a decline in these 15 years of, let's say, 4%. Now we can look at this for other periods in time as well, and then you can see that there were some periods, so 1980, 1990, and 2010, 2014. So that's right after the global crisis, in which the value-added shares were relatively stable. They didn't change very much. But in the other three periods that I distinguish here, and the periods are not equally long, that's something that should be taken into account, there is a clear decline. And over the entire period, if you focus on the value-added coefficients of all industries, they declined by slightly more than 11% using this type of analysis. If we focus on the value-added shares of manufacturing industries only, then the decline was more marked, and it amounted to about 20%. So this is evidence that over time the own value-added coefficients have declined. Then this is a similar graph, and now we look at the sum in columns of the foreign input coefficients, and then again we have 1965 along the horizontal axis, 1980 along the vertical axis. We have the green line again, that's the 45 degrees line, and the red line gives the weighted regression line through the origin. And this time the values on the vertical axis are equal to 1.112 times the values along the horizontal axis. Using the same type of weighted regressions again. So we see that in this period, these 15 years, the foreign input coefficients tended to increase. I have a similar table as before with the elements over time. Then we see there's a strong increase, especially in the period 1990-2000. But also up to the global crisis, there was a strong increase. So this is a slightly shorter period as well. Then afterwards, for the period for which we still have data, at least in the Wyatt database, the situation has become much more stable. If we focus on the manufacturing industries, then again the effects tend to be a bit stronger. So we indeed see that over time, foreign intermediate input coefficients have become much more important than they were before. And if we have a graph like this, but now for the last period, so 2010 to 2014 along the vertical axis, then you can see the difference that there are many more observations here along, let's say in the middle of the graph, and then the scales of the graph are even not identical, so they run up to a maximum of 0.8 on the right hand side, whereas on the left hand side is only 0.6. So there's clear evidence that foreign intermediate input coefficients have become much more important over time. So it's not just this global value chain revolution, it's not just the increased importance of intermediate inputs trade over a final goods trade. There's much more that happened over time. Now, there are different ways in which we can try to analyze the consequences of these, and again, a lot of high-level publications have seen the light based on the MRIOs constructed by our community, and of course, some of us have also contributed to analytical studies related to these. And if you're talking about further avenues of research, you could say, well, we could focus on very different applications. And in evolutionary economic geography, these are called unrelated innovations, or innovations yielding unrelated variety. You can also look at opportunities for more incremental innovations, which are closer to home, if you would call it like this. I think that these new quantitative trade models, for example, are unrelated innovations, and I would like to focus on more related innovations in this talk. Of course, also taking the nature of the audience into account. So I will discuss three things. I will focus on the fact that I think that we should focus much more on ratios between something like CO2 emissions to value added, rather than considering CO2 emissions relative to gross output, as we tend to do in most of our analysis. So that's one thing. Then I think we could do slightly different things related to structural decomposition analysis. I will show that the more traditional ways of applying SDA to global value chain related aspects can lead to misleading results, and I will come up with something that could be an alternative, at least in my view, but as I mentioned already, we could disagree. And then finally, I think that we should pay more attention to differences in activities or functions or occupations rather than to industries and products, and that will be the final part of my presentation. One of the things is that one of the advantages of focusing on these three is that I think that most of the data are actually available, because there's of course a lot of effort still going on, for example, within the OECD on coming up with better data, paying more attention to heterogeneity in production technologies between exporting firms and firms that produce for domestic purposes, differences between large firms and small firms, differences between multinational firms and firms that are domestically owned, etc., etc. And I will not focus on those efforts, although they are of course extremely important for us. Okay, so let's talk first about these ratios with value added in the denominator. So here I have some data which were taken from the 2013 release of Wyatt, in which I have computed CO2 over gross output coefficients for the first few countries in the Wyatt database, so completely at random. Then I have done the same, but dividing CO2 emissions in this electrical and optical equipment industry 2007, not by gross output, but by value added. And here in the third column, I have the ratio between value added and gross output. Now, if we, for example, focus on Australia and China, then you can see that if we focus on CO2 divided by gross output, our more or less standard approach to measuring emission coefficients, that Australia and China are very similar. So there's a small difference, but they are, let's say, in the same range of values. And that would lead to the conclusion that Australia and China regarding this industry are about equally dirty, that their production processes are about as clean or as dirty. Still, if we consider that the value added is much smaller, the value added per unit of gross output is much smaller in China, 0.17, in comparison to Australia, 0.46, then suddenly China becomes much more dirty in this industry than Australia. And of course, if you buy intermediate inputs from abroad or from domestic sources, then you will not emit any CO2 yourself based on these purchases. The emissions will take place elsewhere. So the problem is that given that, as we have seen before, these value added to gross output coefficients tended to decline during the GVC revolution, these issues also have implications for intertemporal comparisons, like what we do in structural decomposition analysis. So here I have two stylized examples. So here we have 1995, when trade in final products was relatively important, but as you see, there were no imports of intermediate inputs into this economy. And we compare this to 2010, when production had become fragmented, and we see that there are imported intermediate inputs into the production process of both industries in this country. So this is just a stylized national input-output table. If you would compute the A matrix with intermediate input coefficients, then the two situations are identical, and also the share of intermediate inputs trade relative to final demand is similar. So nothing happened there. So it's just about intermediate inputs, and in green that are imported, and in green we have the CO2 emissions. And we also see that there are differences in the value-added coefficients, which are due to these imports. Now, if we would use, let's say, standard SDA, a question would be, what explains the economy-wide increase of CO2 emissions from 80 to 100 units? So if I go back here, we can see that in one industry, for example, if we look at the economy-wide CO2 emissions, they were equal to 80 in the initial situation, they were equal to 100 in the later situation. So what explains the economy-wide increase of CO2 emissions from 80 to 100 units? Well, then in the standard approach, we would have three determinants. So we would have cleaner or dirtier production processes indicated by these emission coefficients. We would have change defined as emissions over gross output. We would have change in intermediate input coefficients, and we would have changes in final demand, and this would be the equation that we would use. And then based on the arithmetic average of the polar decompositions that we proposed a long time ago, me and the newly person with the royal decoration, Eric, we would find that there was a decline in the emissions due to technological change. So production processes became cleaner. And we would find that the increase in final demand has had a very important effect, leading to higher emissions. So the conclusion would be we consumed more, but at least our production processes became cleaner. And I think this is a misleading outcome. Because again, if you purchase intermediate inputs, you are not emitting anything yourself. So the own pollution is generated by own activities, by the inputs of labor and capital that actually lead to emissions. So emissions per unit of value added remained constant. So what I would propose here, and again, I don't claim that this has never been done before, but I think we should do it much more often, is that we would have an approach in which we would have four factors. So changes in emission to value added coefficients, that would be a different kind of K. Changes in fragmentation indicated by value added to gross output ratios, and then still changes in intermediate input coefficients and changes in final demand. And then we would have these four factors. And then we would find that given that there is no change in the emission to value added ratios, let's say the cleanliness of the technology did not contribute anything. Instead, we find that the result, the part of the emissions that was initially in the more standard approach attributed to cleaner technologies due to change in fragmentation, due to the fact that things are imported now, and then of course the changes due to final demand does not change. So we would find in this case that international fragmentation, so things related to trade, have led to lower domestic emissions in this country, rather than that technologies have become cleaner. And I think that in, let's say, 90 or 95% or maybe even more of the studies that are published, that we would find, or we would argue that production processes would have become cleaner, basing ourselves on emission to gross output ratios. Okay, let's go to the second part. SDAs aimed at disentangling the effects of technology and trade. And again, I will use the example of CO2 emissions as an example. But of course, the type of methods that I propose can also be used to study other phenomena. So here I have two input-output tables, and these are MRIOs. So here we have, let's say, Germany, the D for Deutschland, and the H for Hungary. And let's assume for now that the world consists of Germany and Hungary. We have a situation in 1995, and we have a situation in 2010. In 1995, trade was in final products. As you can see here, the two blocks that relate to trade and intermediate inputs are equal to 0 in both countries. In 2010, you see that German industries are actually using intermediate inputs from Hungarian industry. So this relates to a situation in which, for example, German car manufacturers had offshored parts of their production process to a country like Hungary. And then apart from that, the world has grown. So all industries are larger than they were before, and you can see that there are also changes in the emissions. So they are equal to 80 in Germany in 1995, and they're equal to 100 in Germany in 2010. So these numbers correspond to the previous example. Okay, we are now going to try to find out whether it's mainly technology or mainly trade that led to this increase in the CO2 emissions. And then in input-output, the common approach, and I think Jan van der Linden and Jan Oosterhaven were the first who came up with this idea, at least as far as I know, back in 1995 in an economic systems research article. They said, well, okay, there are 5 sources of change that can actually explain or account for the change in German emissions. Then first we have the changes due to changes in emission technology and emission coefficients. Then we have the final demand changes, which are both changes in the total level of final demand and the composition of it. Then we have technological changes, which are indicated by A star. And there are changes that are due to changes in the trade patterns, TA and TF. So, for example, if we look at elements of TA, and here we have the typical element TRI as J, that indicates a share of country R and in the inputs from all industries I that are used in the production process of the industry J in country S. So, for example, if we have car manufacturing and car manufacturing uses metal products, then TRI as J could relate to the share of Hungarian metal products in all metal products used in the German car manufacturing industry. So S and J would relate to Germany and the car manufacturing industry. I would then be metal products. And R would then relate to the share or in all the metal products purchased by the German car manufacturing industry from Hungary in the total purchases of metal products. And then if you use this type of approach, then it's quite clear that we have here this cell by cell multiplication, that we have changes in the sourcing pattern of intermediate input. So for example, if we have the German car manufacturing firm BMW, it would take into account that BMW might between 1995 and 2010 have switched from purchasing German domestic metal products to buying metal products from Hungary, for example. And if this would happen, then everything else equal, in Germany, fewer emissions would have taken place. So this is something that is covered by this type of equation as the basis for structural decomposition analysis. Now, I think there are 2 problems, and they are not independent from each other. First, it might well be that BMW did also offshore part of its own activities to Hungary. So its own value added was substituted by foreign intermediate inputs. And that's something that is not taken into account in the more or less traditional structural decomposition analysis. So then there were inputs, the intermediate inputs into BMW, and they could be sourced from various countries, and this pattern could change. But as we have seen already, over time, value-added coefficients have declined, whereas foreign intermediate input shares have increased. And this is partly due to these activities, to these changes, this aspect of the global value chain revolution. And this is an effect of trade, but it's not identified as such, because the A matrix does not because it does not relate directly to the A matrix. The A matrix changes, and hence we would say it's a technology effect, whereas in reality it's a trade effect. BMW would actually offshore its activities, which is made possible due to these new internet technologies and relatively low transportation costs. Then another thing is that BMW will most probably not offshore everything. This depends also on comparative advantages of countries. So it's quite likely that BMW, for example, given the highly educated German workforce, kept its own research and development and the accounting departments, for example, in Germany. But only the relatively polluting fabrication activities were offshored to Hungary and maybe other countries. And this is something that is sometimes quite a fundamental change in the way in which firms have started operating. So there's a famous paper by Bernard and Ford in the American Economic Review 2015 about factory-less manufacturers. These are companies like Apple that are manufacturers in a sense, but they don't have their own factories. Their factories are located anywhere in the world, and they are quite often, from an ownership perspective, independent production units, not owned by Apple itself. But still, if only the more polluting activities are offshore, this shows up as changes in K, in emissions over output. And hence, we as input-output people would say, well, this is a change in the production technology, where the production technology have become cleaner, whereas in effect it's due to a change in trade patterns. So an alternative approach that we could use is focus on what we could call global value chain tables. We have in a paper with Marcel and Geitz and Robert Steere, we have called these global value chain tables, but other terms could be used. They look like input-output tables, but they are different. So here we have again the German and the Hungarian industries. They're also in the columns. Now CG, the column sums, stands for the CO2 emitted in a global value chain for the final products completed by the country industry in the column header. So for example, we would find that 64 units of CO2 would be emitted in the production of German cars, if M would be the car manufacturing industry. And then you would see that 45 of these units are actually emitted by the German car manufacturing industry itself. The German service industry would emit 5, the Hungarian manufacturing industry would emit 7, etc., etc., and then we arrive at 64. And the final output of this value chain equals the sum of final demand for German cars worldwide, which is the 120, which showed up in the original input-output table. So that's what we see in the columns. In the rows, we then find the CO2 emitted by country industries like the German manufacturing industry. So in total, they emit 50. 45 of which is due to final demand for German cars, and 5 is due to final demand for German services. And Germany does not, in this example, emit anything for final products produced by Hungarian industries. Now, you could say that the ratios between CG, so the elements here in this row in green, and F, the value of final output, tell you something about the technology, the emission technology in a global value chain. So 64 units of CO2 are emitted in order anywhere in the world in order to produce 120 units of final product by the German manufacturing industry. And then if you're interested in where this actually has happened, then you look at the share, at the ratios between, for example, this 45 and the 64, or for the Hungarian manufacturing industry, the 7 to the 64. And changes in these shares tell you something about the way in which emissions are distributed over countries and industries in the world, and of course this is strongly related to trade issues. So then, in the next step, one could use SDA based on differences between two global value chain tables, as I showed before, rather than differences between two MRIOs, one for 1995 and one for 2010, for example. And this is something that was more or less done already by Laurie Reinders and Gijs de Vries here in Groningen. They published this in 2018 in the Journal of Development Economics. And then the determinants that would drive change in emissions in Germany would be changes in the level of worldwide final demand, changes in the composition of worldwide final demand, and this could relate to the types of products that are demanded. So is it mainly services products or mainly manufactured products, for example, but also where these products come from. Are these German cars or Spanish cars or French cars, for example? Then a third factor would be changes in global value chain specific emission technologies. So the emissions per unit of global value chain output. So in the previous slide, CG divided by F. And then finally changes in the share of Germany in these global value chain emissions. And all four of these determinants can change over time and can contribute to changes in the emission levels in Germany. And if you would use this type of approach, you would take into account this offshoring aspects of BMW actually offshoring part of its own activities to Hungary or other countries, something that is not taken into account when we use the more traditional input-output based, MRIO-based structural decomposition analysis. Then the question is, of course, okay, how do we obtain these global value chain tables? And I have some ideas about this, which I would like to share. So the elements of this G have been discussed already. So it stands for the emissions of industry I, country R, needed for the production of final product J completed in country S. So again, products that are like cars, that would be final product J that are finalized in Germany, country S, and then how much does the Hungarian industry I, and R would be Hungary, industry I would be the manufacturing industry in Hungary, how much does it contribute? These are the typical elements of such a global value chain table. And due to all kinds of pressures by politicians, but also by society at large, there are huge numbers of large producers that are reporting more and more about their own supply chains. And this is part of all kinds of corporate social responsibility codes, etc., which provide all kinds of information about emissions, but also about labor earning less than a minimum wage, for example, across countries in the supply chains of these firms. We have also information apart from this, so this is mainly firm level information, but quite often for large firms, we also have information from the MRIOs, and I think that there are opportunities, increasing opportunities to combine information from the MRIOs, and then if we would only use this would be the expression for G, to merging these with corporate social responsibility data to arrive at better global value chain tables, which can then be compared over time. So this equation for G is very standard in the literature. So most global value chain tables, as we see them currently, are actually based directly on MRIOs, and these other types of firm level data are not taken into account. They are not considered. Okay, then finally, I would like to make a plea that we should focus more on difference in functions or occupations or activities rather than on just focusing on industries as we usually do in input-output. So in 2008, Gene Grossman and Esteban Rossi-Hansberg published an influential paper in the American Economic Review, in which they say that in a global value chain world as we have it now, countries trade in tasks or in functions rather than in products. And this is something that is also recognized in the international business literature by people like Ram Mudambi in Journal of Economic Geography. And he says, well, if a product is produced, there are different types of activities involved, research and development, design, the actual fabrication, the manufacturing activities, the provision of standardized services that relate to it, but also things like marketing, advertising, organizing, worldwide logistics, etc., after sales services. And there is a lot of evidence that what is sometimes called the pre-production activities, so R&D and design, and the post-production activities like marketing and logistics, that a lot of value added is generated there and only very little is actually earned in manufacturing or in fabrication activities. And countries specialize in this. So China, but also countries like Vietnam and Bangladesh are clear examples of countries that specialized in the fabrication activities. And for China, this might change. So China is upgrading and is now also moving towards the left and towards the right, going into more value-adding activities in the production of products. So if we look at the horizontal axis here, we move from pre-production functions to post-production functions, and this is then called the smile curve. Now, input-output people have also contributed recently to this literature on smile curves. So there's a paper in Oxford Bulletin of Economics and Statistics by Ye, Meng, and Wei, recent paper. And they come up with this type of graph. And well, this is something that looks like this smile curve with a bottom in the middle and much higher value added shares at the left and the right. But, and this is something that makes the story quite different, the horizontal axis here does not relate to pre-production and post-production activities, for example, but to upstream, to upstream sectors on the left and downstream sectors on the right. So the distance to final users is indicated here. And then they say, well, this is also a smile curve, and indeed it's a smile curve, but it doesn't say anything about activities. This is about being specialized in the production of natural resources or being specialized in the production stages related to finalizing products, in some cases assembly. So this is a different story, and I think that we should try to focus more on this idea of functional specialization. So in a paper in 2019, Marcel Timmer and Sébastien Miraudot and Gijs de Vries, they have used a database based on occupations, and they say, well, the management function is done by financial managers, human resource managers, for example. Research is done, the research and development function is done by engineers, computing professionals, etc. Marketing is something done by people in occupations like salespersons, etc. And fabrication is done by assemblers, machine operators, and other types of jobs related to this. And then they argue, and this is a graph that was constructed by Luc Appels, that countries vary quite a lot. So here we focus on one specific industry, the chemicals and the chemical products industry, and the colors relate to the shares of these functions.
No.
Sorry?
Es que el chucrú no está crudo. El chucrú está...
Oh, sorry, I heard someone. Okay, so on the vertical axis, we have the shares of functions in the total income earned in this industry, and then in various countries. So, for example, we can focus on China and Germany, both relate to the chemicals industry. But then we see that more than 60% of the labor income earned in the Chinese chemicals industry consists of activities done by assemblers and machine operators, so the fabrication function. Whereas if we focus on the German chemicals industry, only something like 23-24% of this labor income is generated by fabrication workers, by people responsible for the fabrication function. And if we focus on Sweden and the US on the right, then we can also see that the pattern is very different from Russia and China, and to a lesser extent Bulgaria. So it's very hard actually to compare the chemicals industry in China to the chemicals industry in Germany. Also, if we focus on CO2 emissions. So here we have along the vertical axis the CO2 coefficient. So that's in the traditional way CO2 the emissions divided by gross output. On the horizontal axis we have the fabrication income share in total labor income. And then we have a regression line, and we see that it's upward sloping. So the higher the share of fabrication in the activities in this chemicals industry in 2007 across countries, the more polluting these industries are, because then, of course, machinery is used, and everybody who thinks of these smokestacks relates his or her views to actual fabrication activities. So we can meaningfully, in our view, or in my view, compare the chemicals industry of Russia and China, and then see that the Russian chemicals industry is much more polluting than the Chinese chemicals industry. But we cannot say that the Chinese, meaningfully say that the Chinese chemicals industry is about twice as polluting as the German chemicals industry, simply because the activities that are conducted in these industries are across countries are extremely different. They cannot be compared in a meaningful way. You cannot compare a chemicals industry focusing on management and research and development to a chemicals industry that is mainly doing fabrication activities. And this, of course, also in a similar vein can be related to the use of energy. So the story is more similar here. So we, as input-output people, have already agreed that the domestic technology assumption can be misleading. So just focusing on CO2 coefficients and then say, okay, in China and in Germany, they should be the same. Because there are differences in these technologies across countries. But apart from that, or besides that, we should also realize that these industries are doing very, very different things. And that has also implications for example, the Armington assumption in trade models, where we would argue that Chinese chemicals substitute as easily for German chemicals as French chemicals substitute for German chemicals. And that's not true, because the activities, the functions performed in these industries are very, very different. And I think these are issues we should pay more attention to. So finally, and then I will conclude because I think I'm running out of time already. I think that the global value chain revolution has made input-output much more relevant. I think we agree on that. We have, as a group, contributed enormously to the construction of these databases that are widely used. And then I have some reflections that are a bit more provocative, maybe. I think that we have not improved or renewed our method sufficiently to stick to the frontier or to get to the frontier using these new type of data. And I also think that this is partly due to the fact that we are not open enough to developments in other subfields. And I think we should do more than measuring. We should also be capable of doing more than measuring. And I think it's really important that we focus much more on what's actually happening in international trade literature, in the growth and development literature, etc., etc. But of course, this is something about which I have my own personal opinions, and these are opinions that are not necessarily shared by others. But yeah, I would like to tell it like this, and then of course we can discuss this further. Thank you very much for your attention, and I hope that there will be time for some discussion. And afterwards, questions and comments can of course always be sent to my email address. Again, thank you very much for your attention.
Okay, thank you very much, Bart, for your inspiring talk. And yes, now it's time for questions, for comments. You can raise your hands, and Jorge and Mia, we try to organize the, the discussion. I think the first is Bert Stent.
Yes. You see me, hear me?
I see part of you,
Yes.
Bert.
Oh, okay.
Yes.
This more part.
The upper part.
Okay.
But we can hear you.
The shiny part.
Oh,
The shiny part.
okay, thank you for the compliment. Well, anyway, I was wondering a little bit, you talked a lot about new methods that we have to take a look at, and various kinds of ratios that we have to study and that are emerging. But I was wondering a little bit, in your talk you hardly addressed, let's say, prices. And I've been educated with Leontief modeling, and there you have physical stuff and you have price stuff. Is the time for, let us say, a kind of input-output like price analysis? Is that more or less gone because you throw away in your proposals a little bit, let's say, industries, etc., for products and functions, etc., which perhaps are more difficult to add a price to? So is price analysis in an input-output context on the way out? Doesn't it fit in?
I don't think so. Well, first of all, at least one of the papers that I mentioned in my list of, let's say, mainstream applications that have become possible due to the availability of the MROs is the paper by Auer et al., which is about inflation spillover. So that's clearly related to prices, and there is a larger literature about that. So there are definitely applications of input-output related to prices. Then I think that also when it comes to issues like functions, for example, you cannot compare the productivity of a chemicals industry focusing on fabrication activities to a chemicals industry focusing on research and development and management in a meaningful way. Well, if productivity levels differ from each other, then this will most likely also yield differences in prices, at least if you believe in competitive pricing to some extent. One of the problems, of course, is that multiple functions are present, as I showed in the graph, in one industry. So all four functions, and you could also use more detailed classifications, are present in one industry. And that means that sometimes econometric approaches are needed, relating the price of products to the share of fabrication in activities and the share of research and development in activities in an industry, for example. So I think that, let's say, standard applications of the Leontief price model might be harder. But I think that there is a lot of data that could be used using more econometric techniques rather than the, let's say, the purely standard input-output approaches.
Okay, well, thank you.
Thank you, Bert. Second hand, I think, is Sofia from Zaragoza.
So hi, can you hear me?
Yeah, hi Sophia, I see you and I hear you.
Nice to meet you again.
Yeah.
So congratulations for your presentation. It's been really nice and inspiring. My question is related to what you saw at the beginning of the presentation, what is called long run WIOT or something like that.
Yeah.
I was curious about that because I think it's very interesting to have a historical database, and I was wondering if it's a new available data set or something like that.
Okay, thank you. Yeah, the data is not available yet, so we are currently still, let's say, debugging the data. So Chanja, he was responsible for making this bubble plot, and also one of the line plots in which I showed the share of intermediate inputs trade in total trade. And when we or Chanja created this graph for the first time, we found some strange discrepancies between the various databases. So we went back to Job, who is a colleague of ours, who is mainly working on this historical database, the long run database. And he started, and he found a mistake. So we are still in this stage. But I don't think that it will take very long before the data will be made public. The data runs from 1965 to 2000. It contains all the countries that are also in WIOT, apart from the Eastern European countries and let's say the former Soviet Union, because data are not available before the Iron Curtain fell. But apart from that, the data is very similar to what you find in let's say the regular WIOT. I can't, also because I'm not responsible for this data myself, I can't promise anything about when exactly the data will become available, but we are, I think we are close to finalizing the data, and then they will be made available via the WIOT website. I don't know if that's an answer to your question, but...
Yeah, of course. Oh. And I have another question, if I may. That is that you didn't mention anything about risk disruption, the risk of the disruption of the change. And now
sorry,
the risk of the disruption of the change.
Yeah.
And I wanted to know your point of view of that, because now with the coronavirus crisis, we saw that this can happen, and not because of economy issues, but because health issues. So I wanted to know, how do you see the future research in that sense?
Yeah, I think that one of the most interesting questions will be whether, let's say, the world will return to the old situation regarding the international fragmentation of value chains. There are people who say, well, there will be a lot of reshoring because countries feel that they should produce many of their intermediate inputs closer to home. That research and development and fabrication should be co-located, etc., etc. But I'm not so sure, because in the end there will remain competition across firms. A lot of this fragmentation is due to driving costs down, quite often also related to using or benefiting from economies of scale. So I think there will still be countries in the world that specialize in specific types of activities, sometimes within specific industries, sometimes across industries. But I think there will be more diversity. So I can imagine that a Spanish firm, for example, will have parts of its intermediate inputs of a specific type still being produced in China, but another part in the Czech Republic, for example. So that if something happens in the Czech Republic, they can rely on the intermediate inputs from China, or if something happens in China, they can rely on the intermediate inputs from the Czech Republic. So I think there will be more diversification, but I'm not sure, of course. And I think this is indeed one of the nice types of research that can be done by people in our community.
Okay, thank you very much.
No, you're welcome.
Thank you. More questions? Okay, I have one in the meanwhile. Okay, I'm also interested in what you call the functional specialization and the type of data that you are using about this, because I think that this is a first step to go to the analysis of one issue that I think is irrelevant, that is the social effect in terms of income distribution between social groups, the consequence of the global value change. And if I have seen something about this, I think this information is irrelevant, not only to see which part of the chain is assigned to one or a different task, but also the repercussion in terms of income distribution between social groups in the different countries. I think it's a question, an interesting question to analyze, and in which perhaps input-output community could also contribute.
Yeah. Okay. Yeah. Thank you. I think that's correct. Of course, there is this literature on job polarization, for example, quite often not based on input-output analysis, yes. But this literature finds that robotization, but also international trade, has led to situations in advanced countries where wages and employment of high-skilled people went up. Quite often, really low-skilled people were not affected very much, but it's mainly medium-skilled people with routine-intensive tasks that suffered from this, like car manufacturing workers in the United States, in the Midwest, for example. And if you have data on occupations by industry for many countries, like appended to an MRIO, then you can indeed analyze issues like these. That's true, and you could, in principle, try to figure out whether it's mainly technology or mainly trade that has actually caused this type of change in the employment mix and in the relative wages of people with different occupations. So that's correct. So I think there are opportunities for doing that.
Another question?
Rosa, can I ask Jeff Ewings? Yeah, thank you, Bart. This is really interesting. I'd like to try to see if I can connect Sophia's and Bert's questions, because you mentioned the case of a firm having supplies in the Czech industry, in Czechoslovakia and in China. But one of the great advantages of the value chain is you specialize the fragmented production in the location which is going to yield the most benefits to you. In other words, the cheapest cost. And so I think the need to have some sort of price information is important. How do we measure the increased vulnerability that places on a set of activities, as opposed to having those options in the event of some disruption? And I think it will require some very, very careful analysis, perhaps to separate the value chains by the different locations of the activities, meeting a very similar final product. And a very good example of this problem is in the Boeing production of the 787, where they relied on different locations for the provision of certain parts. And what they found was the quality of parts from location A were not Armington perfectly substitutable with the same product from another location B. But having more than one source increased coordination costs.
Yeah.
In other words, the Ford company found that they had 10 or 12 suppliers on average for the same component, but the quality differences were such that it cost them a lot of money to coordinate this, to make sure they were sane. So what it would require is a sort of integration of the pricing system with notions of vulnerability and risk, and then map that into sort of a modifications of your smile curve by different patterns of location. And I think that would be a very, very interesting innovation that would help us, I think, promote something that is now very, very concerning as a result of COVID, as a result of floods, earthquakes, and unexpected events. Thank you anyway for a very, very nice, stimulating presentation.
Okay, thank you, Jeff. Yeah, well, I think I agree. Of course, one of the issues is that vulnerability is multifaceted in the sense that you can be vulnerable to the effects of a COVID outbreak in a country, but you can also be vulnerable to an important transportation route being blocked, like the Suez Channel. And it might be hard to come up with a very reliable vulnerability indicator that takes all these different types of vulnerability into account. That might be problematic. But I agree that firms will have to make trade-offs between, let's say, the cheapest production options in, let's say, regular times, and being able to adjust quickly and at relatively low cost if one or more of these production locations cannot function fully anymore. But yeah, it's definitely interesting, but it might be hard. But well, that's what we are researchers for. So so I agree that this is an interesting issue. To which we might be able to contribute. Of course, there are always issues of aggregation levels, so that's always an issue.
Okay, we have two more questions. First, Michael R. No.
Bart, my question is one I know I've asked you before, but I think it always begs being asked again, and we've been bouncing all around it with the questions so far. And one, getting at things COVID related, given things like Zoom and so forth, trade and services is going to be even harder now to track, and I think it's going to become more international in light of this. So my question would be, how will this be transformed into trade statistics, or how much will we be missing in all this? And then related to that is the nature of firms that tend to trade versus that don't tend to trade, and how they're, one of the reasons the UN is going to the new form of production of processing versus non-processing production. But even with full regular manufacturing, we have differences in processing between large and small firms, and the large ones are the ones that tend to trade. So I'm wondering how well IO tables actually track the nature of what is being traded.
Mm-hmm.
Even with the same item, even with an iPhone or a smartphone.
Mm-hmm. I think that's a point of concern indeed, especially because a lot of this trade and service is actually happening within firms. So multinationally operating firms who provide for example, research and development services in one country, and let's say the blueprint that is yielded by these research and development activities is used in another country. So, for example, Apple doing its design activities in California and using these designs in the production activities in China. And this is extremely hard to measure this correctly. I fully agree, and that is why it might be good if this idea, I think this was mentioned by Ivo Havinga at the Atlantic City conference in his keynote, that this global value chain type of statistics are also compiled and then somehow be merged with input-output tables. I don't think we can rely on one of the two. So we need the input-output tables for, let's say, the macro picture, because otherwise you would have to find or to collect information on tens of thousands of value chains, which is impossible. But I think that if you would somehow use the national accounts based input-output tables and merge these with, let's say, the information on the most important, largest global value chain statistics that are collected in other ways, that you might arrive at something that can be useful for this type of analysis. And using these global value chain statistics, you might also get a better grip of the trade in services within these global value chains. But trading services will remain problematic. I think that irrespective of how much efforts will be put into arriving at better statistics, they will always be worse than trading good statistics. So it's a concern indeed.
José Manuel?
Thank you, Rosa. Thank you, Bart, for this excellent presentation. So related to exactly what you have just said, my comment would be related to the UN Handbook on Global Value Chains Accounting that Ivo Avinga has promoted or pushed forward. So, and the main idea, I mean, this can complement, I mean, there is, I think, room for input-output analysts here. So the main idea is to focus on one value chain, automobile industry, for example. Then you map the governance, I mean, which are the main multinationals, where the different functions are located. And then you frame all that information into an input-output style table. I mean, instead of industries, you have the business functions. Instead of all products, you have only those related to the automobile industry, I mean, in a very detailed way. Then you have trade statistics, you have business information. You know, the handbook provides some guidelines for statistical offices or, you know, anyone who would have that information. Yeah, I'm putting it in a framework of IO, final demand, intermediates, value added, etc. And, you know, it's something in between. I mean, it's not macro, but you focus on a value chain, you look into it, which are the main countries, not all of them. And then you aggregate the rest of the world, I mean, what is not important for that value chain. And then you know, there's a lot of room to improve and to do in this approach. And it can still be done with input-output. So, I mean, it's interesting, I mean, to see it. I mean, it was just for your information that this handbook is on the web. I mean, it's still in a white paper, I think. I can send you the link to everyone. And yeah, have a look. I mean, there's a lot of room there. Thank you.
Okay, thank you. Yeah, well, again, I think this is really helpful, but still, if you would be interested in the type of question that Rosa, for example, suggested, then we still need this macro perspective. So I think these two different types of data should somehow, or effort should be put into somehow integrating these two types of data, because otherwise you come close to, let's say, the more case study type of research into global value chains, which is very useful. It leads to all kinds of very deep insights. But there are always questions about questions about the extent to which results are generalizable to other global value chains, for example. So if you are mainly interested in macro questions about, well, consequence for inequality, for example, then I think we can't do without an integration into, let's say, more traditional input-output tables, which are based on national accounts. So I think the two should somehow be integrated, and that will be hard, but I think that would be an interesting challenge that could help our field further.
Yeah, indeed, Bart. Yes, I agree. I mean, part of the micro data, I mean, it's needed to fill in these new satellite accounts that the UN is proposing. Yes.
Okay, any other question, comment? I don't see the room. Okay, so it's 6:30 and we can start to close. Thank you very much, Bart, for your presentation. You are always very welcome at SHAIO. And let me just to close to announce that the next webinar will be in May and will be talked by Luis Pedagua from the University of León. And is correct this? Yes. And that in the coming days we will announce the workshop of the SHAIO that will be held in León. And for this workshop in September this year, and for this workshop we will try to implement a double line, an online line, and also a face-to-face discussion, something like that. So we will see our announcement in the web, and okay, we can talk. Okay, so thank you very much, everybody, for attending this meeting, and we hope to see you again next month. And that's all.
Thanks for the questions and the suggestions.
Thank you.